Welcome to the SWAYAM NPTEL course on food microbiology for safe and sustainable food systems. We were discussing beneficial microorganisms in food. In the last lecture we have discussed food fermentation, and in this lecture we will be discussing starter culture. And the topics which we will be covering is introduction, definitions, history of starter cultures and fermented milks, preparation of starters, role or functions of starter cultures, types of starters, characteristics of a good starter culture, factors affecting fermentation process of starter cultures, and types of fermented milk. The introduction. Starter cultures are those microorganisms that are used in the production of cultured dairy products such as dahi, yogurt and cheese. The organisms selected for this purpose of need to produce the desired effect in the finished product. Starters are a group of active and desirable microorganisms capable of bringing about desirable changes in the milk product through the process of fermentation. These are carefully selected microorganisms that are deliberately added to milk to initiate or to start and carry out the desired fermentation in the production of fermented milk products. In other words, starters being about the specific changes. In other words, starters bring about the specific changes in the appearance, body, texture and flavor characteristics of the final products. The natural microflora of the milk is inefficient, uncontrollable and unpredictable and destroyed altogether by the heat treatments given to the milk. A starter culture can produce particularly characteristics in a more controlled and predictable fermentation when added to milk. The most common use of starter cultures is for the production of lactic acid from lactose, that is the milk sugar, which in most cases causes or assists in the coagulation of milk protein by lowering pH of milk. Cultures that produce lactic acid are generally referred to as lactic acid bacteria, or in short LAB. Certain starter organisms are added specifically for their ability to produce flavor compounds such as diacetyl. Starter organisms can also influence texture of culture and are aged products through the breakdown of proteins, fats and other milk constituents in addition to the pH effect. The lower pH of cultured products can be inhibitory to certain spoilage organisms, although inhibition is associated with other byproducts of growth with some starters. More recently, probiotic cultures are finding their way into cultured milk products. These organisms possess some claimed health benefits for the consumer, for example, better digestion, anti-cancer compounds and prevention of heart diseases, etc. Probiotic cultures may be added as adjunct or they may be directly involved in the fermentation process. Now the definition. Starter cultures are bacterial or fungal strains, either pure or mixed, used to initiate a fermentation process. The culture includes selected strains of food grade microorganisms of known and stable metabolic activities, and that is used to produce fermented foods of desirable appearance, body, texture and flavor. Starter culture means the microorganisms that are selected based on their ability to produce lactic acid for curd production and a low pH to prevent spoilage, produce metabolites that give desirable flavors or produce enzymes that ripen the dairy product. Now, the history of starter cultures and fermented milks. The pure culture techniques in microbiology were not developed until Pasteur in 1860s. Similarly, lactic acid bacteria were identified by Lister in 1870s. It is important to note that an industry developed technique to produce pure cultures only a short time later. Storch in Denmark, Wigman of Germany and Kohn of USA in late 1880s showed that pure cultures could be used to ripen cream, and soon the role of flavor producing bacteria, that is citrate fermenting diacetyl producers, was established. By 1878, Christian Hansen began a culture business that continues even today to a major supplier of starter cultures for the dairy, meat, brewing, baking and wine industries. Initially, starter strains were prepared by the manufacturer by growing pure strains in heat sterilized milk. Calcium carbonate was added as a buffer in order to maintain a natural pH. Calcium carbonate was often added as a buffer in order to maintain a neutral pH. These liquid cultures remained popular until relatively recently, even though they had a relatively short shelf life due to the loss of cell viability and fermentative ability. Eventually, rather crude dry culture preparations were produced which required several transfers in milk to receive the culture to an active state. Freeze-dried cultures also became available, but the early product also required growth in intermediate or mother cultures. Frozen cultures, now the most common form of dairy cultures, were not introduced until 1960s. Significant improvements in freezing and freeze drying technologies have led these types of cultures to dominate the starter culture market. The modern starter culture industry provides cultures for nearly every type of fermented food and beverage. This chart shows the preparation of starters. In this we can see the first reconstituted skim milk of 10 to 12% solid heated to 90 to 95 degrees Celsius for 30 to 40 minutes or 121 degrees Celsius for 15 minutes. This is the substrate preparation for starting a culture medium. Then it is cooled to 20 to 30 degrees Celsius for mesophilic culture development and 42 to 45 degrees Celsius for thermophilic cultures. After that, the pure culture it was added at 0 to 4 degrees Celsius temperature, and it is continuously for 1 to 2 weeks, and random purification is required for that. And once the pure culture is developed, then it is inoculated further, and many times it was inoculated to cultivate this thing at temperature determination according to the strain characteristics which we have discussed so far, that is the mesophilic culture and the thermophilic cultures, for 3 to 20 hours. And after the mother culture is prepared, then reconstitution is done in the substrate which has been prepared, and then it is stored for the further application. And the substrate which has been prepared for inoculating the mother starter culture, it was cooled and then it was added. So, at desired temperature only it has to be added. The propagation and preparation of lactic acid bacteria starter cultures is one of the most important operations in a dairy plant required for manufacture of fermented products. Since the quality of a starter has a direct bearing on the quality of the final product, starter must be pure, alive and in good shape. Role or functions of starter cultures. The primary function of almost all starter cultures is to develop acid in the products. The secondary effects of acid production include coagulation, expulsion of moisture, texture formation and inhibition of flavor production, and initiation of flavor production. In addition to these, the starters also help in imparting pleasant acid taste, confirming protection against potential pathogens and spoilage causing microorganisms, and providing a longer shelf life to the product. A starter culture consists of food grade microorganisms that on culturing in milk produce predictable attributes. This table shows the common starter cultures used in preparation of different dairy products, like for example this Lactococcus lactis subspecies lactis and Leuconostoc lactis subspecies cremeris. This is used for the acid production, and generally it is used for production of fermented dairy products like cultured buttermilk, sour cream, cottage cheese, all types of cheeses, whether it is domestic or foreign origin, and the starter cultures. Likewise, the Lactococcus lactis subspecies diacetyl lactis is used for acid and flavor production simultaneously, and it is used for producing sour cream, ripened cream, butter cheese, buttermilk, starter cultures, etc. Like Streptococcus thermophilus, that is mainly used for the acid production in Emmental, cheddar and Italian cheeses and yogurt production. Streptococcus durans and Streptococcus faecalis, these are used for simultaneous production of acid and flavor, and generally used for production of soft Italian, cheddar and some Swiss cheese varieties. Leuconostoc citroborum, Leuconostoc dextronicum, this is used for only flavor producing, and it is used for production of cultured buttermilk, sour cream, cottage cheese, ripened cream, butter and starter culture. Lactobacillus delbrueckii subspecies bulgaricus, it is used both for acid and flavor production, and it is used for Bulgarian buttermilk, yogurt, kefir, kumis, Swiss, Emmental and Italian cheeses. Where lactic acid Lactobacillus acidophilus, that is used for acid production in acidophilus buttermilk. Propionibacterium shermani, it is used for flavor as well as eye formation in Emmental and Swiss cheese. Generally, these types of starter cultures are used in dairy industry for manufacture of a variety of fermented products. In general, organisms that grow at ambient temperatures are termed as mesophilic cultures, and those growing at higher temperatures are called thermophilic cultures. Dahi and other Indian fermented milk products use mesophilic starter cultures, whereas yogurt uses thermophilic cultures. Now, let us see the functions of starter cultures. The acid production, that actually due to acid production in the product that is used for the gel formation, expulsion or the synthesis of whey for texturing, preservation of milk, helps in development of flavor. When the flavor is produced, that helps in formation of flavor compounds like diacetyl and acetaldehyde, that is the also used for preservation, and it causes the preservation by lowering the pH and redox potential, production of lactic acid, production of antibiotics, production of hydrogen peroxide, production of acetate. Sometimes the gas is also produced, which is essential for the eye formation in certain cheeses and production of open texture, for example blue bean cheese. It can also be act as a stabilizer in the development of body and viscosity, for example polysaccharide materials. The lactose utilization, it reduces the development of gas and of flavors, and this is suitable for lactose intolerant people. Lowering of redox potential, that helps in preservation as well as helps in development of flavor. Sometimes proteolysis and lipolysis is also caused, which helps in ripening or maturation of cheeses, and miscellaneous compounds are formed like alcohol in kefir and cumins, which is essential for those products. Now, types of starters. In general, 3 different types of starter cultures are used in dairy industry for the manufacture of a variety of fermented products. For example, the single strain cultures. The single strain starter is a pure culture of lactic acid bacteria such as Lactococcus lactis subspecies lactis or Lactococcus lactis subspecies cremoris, etc. This type of culture, if found satisfactory in vigor and flavor, it gives a steady acid production and thereby a predictable quality of fermented milk product. However, there is a serious disadvantage with this type of starter, as during its application, if it gets attacked by a phage or fails due to any other reason, the quality of the resultant product can be adversely affected. An ideal culture for fermentation should possess the following attributes: organisms must be pure, organisms must grow and reproduce quickly, it also must be genetically stable yet amenable to manipulation for better performance, it also must produce uniform product in a short time, it also must not produce undesirable byproducts, and must have a protective mechanism, for example acid or bacteriocins production against other undesirable contaminants. Now mixed strain cultures. These consist of two or more strains or species and thus may be more variable in behavior. The mixed strain cultures are generally combinations of Lactococcus lactis subspecies lactis and Lactococcus lactis subspecies cremoris and the gas and aroma producing mesophilic lactic acid bacteria, for example Lactococcus lactis subspecies diacetylactis and Leuconostoc species. Mixed starters are considered safe because if one strain is attacked by a phage, the others usually continue to work because of high phage specificity. A wider tolerance to other factors like temperature and pH changes etc. may be an additional advantage. The another type of starter culture is multiple strain starters. Multiple strain starters are mixture of non-compatible, non-phage related, carefully selected strains which give generally consistent products when used commercially for production of fermented milk products. Although their overall phage relationships may be known, the number of individual phage relationships among the strains in these cultures to relatively unknown. A multiple strain starter culture consists of known number of single strains so that the starter can be used for an extended period of time. Now the characteristics of a good starter culture. The following desirable characteristics must be looked into for exploring them for full fermentation potentials while selecting a particular lactic acid bacteria starter culture, either single or combination with others for manufacture of fermented milk products. The lactic starter culture must produce sufficient lactic acid at desirable rate to suit the plant schedule and produces high quality product. Good lactic acid bacteria culture must continue acid production over the appropriate range of temperatures at which it is likely to be used during the processing of milk into production of fermented dairy products. The lactic acid bacteria starters should be resistant to antibiotics and bacteriophages. They should also be active in the presence in inhibitory substances as well as residual amounts of chemicals, sanitizers and detergents in milk. A good starter culture should not produce bacteriocins and bacteriocin like substances or any other antibiotic type of substance inhibiting other strains in the mixed culture. A good lactic acid bacteria starter culture should produce desirable flavor, aroma, consistency, body and texture in the fermented products. The use of starter cultures producing certain defects like ropey body, malty or any other undesirable flavor and similar other defects should be immediately discontinued. In case of mixed cultures, the individual cultures must be able to synergize maximum aroma and flavor production without inhibition of acid production. The associative action of mixed cultures must be quite stable and contributes towards the development of a good starter culture even after repeated subcultures. Now, the factors affecting fermentation process of starter cultures. The fermentation process of lactic acid starters can be influenced by several factors such as temperature, pH, strain capability, growth medium, inhibitors, bacteriophage, incubation period, heat treatment of milk, etc. There is a need to take adequate precautions to achieve the optimal activity of lactic acid bacteria during the manufacture of fermented milks. Some of the important factors affecting the growth and activity of lactic starter cultures are described below. The first is temperature. Temperature is one of the important factors which directly affect the growth of microorganisms. Although different types of lactic acid bacteria have different optimal temperatures for their growth, the majority of lactic starters such as Lactococcus lactis subspecies lactis, Lactococcus lactis subspecies cremoris, etc. grow optimally at 27 to 32 degrees Celsius. On the other hand, Streptococcus thermophilus and some lactobacilli grow best at 37 to 42 degrees Celsius temperature range. However, Leuconostocs have their optimal temperature at 20 to 30 degrees Celsius. This variation in optimal temperature requirement may be a very important factor in strain dominance in mixed and multiple starters. Another important factor is pH, which can influence the growth and metabolic activity of lactic starter cultures during milk fermentations. Although milk is considered to be nearly a perfect food for man as well as bacteria, it still needs some enhancement for use as a bulk starter medium. Lactic acid bacteria produce lactic acid at the level of more than 10% of their weight per minute after their growth in milk, and thus pH of milk is lowered. The extreme acidic pH could be detrimental for the viability of lactic acid bacteria. Hence, control of pH in milk during propagation of starters is very important. Both externally and internally, pH controlled media used for the preparation of bulk starters. Now, the strain compatibility. Mixed starters have been used for the preparation of several fermented dairy products. The main objective of using a mixture of strains in mixed culture is that even if one strain becomes infected by a specific bacteriophage, the other strains would be unaffected and enable the culture to produce adequate acid during culture preparation. Same thing may hold good for antibiotic resistance of some strains in the mineral cultures, which will not be affected by the presence of inhibitory substances in milk, and the milk fermentation cultures also plays a very important role in bringing about the desirable changes in milk. Growth medium. The media used for the cultivation of lactic acid bacteria are quite complex. The most widely used growth media are MRS, that is Diamine rugosa and sharp, which is a selective culture medium used to grow lactobacilli, and M17. This is a bacterial growth medium used to cultivate and enumerate lactic streptococci or Ehrlich's medium. Apart from these media, lactic acid bacteria also grow very well in milk. However, it is pointed out that during specific seasons of the year, more inoculum may be needed during milk fermentation in order to achieve the same type of acid production obtained with lower inoculum rates at other times of the year. The inhibitory substances. The growth and activity of the starter cultures in milk is adversely affected due to the presence of residual antibiotics and sanitizers in milk, as well as the production of antibiotic-like substances, that is bacteriocins, by certain wild strains of Leuconostoc lactis, subspecies lactis, and other lactic cultures in raw milk. Now, the bacteriophages. Bacteriophages are considered as one of the single most important factors causing slow acid production by lactic acid bacteria in the commercial environment. The most promising solution to this problem could be by replacing the phage sensitive strains with phage resistant one. This table shows different types of fermented milks along with their origin and the milk used for their production and the microflora used for the production, like dahi, Shrikhand and lassi. The origin of this is India and Persia. Mostly cows and buffalo milks are used, and the starter cultures used for dahi is Lactococcus lactis, subspecies lactis, etc. And for Shrikhand, the Streptococcus salivarius, subspecies Thermophilus, etc. And for lassi, the same, that cow or buffalo milk is used and the Streptococcus salivarius subspecies Thermophilus is used. For cultured buttermilk, it is originated in the countries like Scandinavian and European. Cows and buffalo milk are used, and Lactococcus lactis, subspecies lactis, etc. are used. Likewise, acidophilus milk, that is the originated from the Australia, and mostly cow milk is used, and Lactobacillus acidophilus is used. For yogurt production, it is most originated from the Middle Asia and Balkans. Cow milk, goat milk and mixed milk are used, and the Streptococcus salivarius species are generally used. For kefir, it is origin of country is Caucasus. Sheep, cow, goat and mixed milk are used, and generally the skin bags are and wooden barrels are used. The strains used are Lactococcus lactis, subspecies lactis, Leuconostoc species are generally used. Kumis, the origin is Asiatic steppes, mare, camel or ash milk is used, and the fermentation utensil is skin bag. And Lactococcus delbrueckii, subspecies bulgaricus, etc. is used. For Lebanon and Lebanon, the Lebanon and Arab is the main origin of country. Here the goat, sheep milk is used, and the skin bags or earthenware are used for the fermentation as a fermentation vessel, and Lactococcus lactis, subspecies lactis, etc. are used. That's all for today. Thank you very much.